actually received his Bachelor's of Science with first-class honors and a Master's of Science degree from Electrical and Computer Engineering. And the university, you have to say it for me.
Xi'an.
Xi'an University in China in 1999 and then 2004 respectively.
Exactly.
For the bachelor's and the master's.
Yes,
he
yes.
earned his PhD degree in computer and electrical engineering from the University of Nebraska, Lincoln in 2008.
Yes.
Cornhusker.
Cornhuskers, go.
He continued his research at the University of Nebraska, Lincoln as a postdoctoral researcher in 2009. His current research interests are in the areas of wireless communications and multimedia signal processing. Professor Hua is a senior member of IEEE, and he has served as an associate editor of Wiley Security and Communications Networks Journal. Thank you for being here.
Thank you, Filter. So today I would like to introduce this topic. So image detection, recognition, and 3D construction for net zero energy buildings. So our expectation is to use automatic software solutions for this energy efficient house solutions. And about my background, I have been in Lawrence Tech University since the year of 2010. And one of my research interests is in the image signal processing, and also another one is the wireless sensor network. So this topic is relevant to my research area too. So about the research background of this, so because the trend of the building functionally, including we need to personalize the house and we make the indoor life comfortable, and we expect a low energy consumption and experiment expects. But the truth is actually more than 75% of the expense actually is occurred in the operation period. And also something more is about 50% of the energy actually is wasted. And up to 70% of the service costed actually could be saved by some method. And another important truth is actually at least 60% of the houses in USA actually was built in more than 30 years ago. So this actually caused the trouble for engineers to remodel that and to gain some more energy efficiency efforts for that. So we got the idea about the smart building solutions. So if we have this automatic detection, moderating, and optimization software to do that itself, and in that software, the artificial intelligence algorithms will be embedded in the system, the hardware and the software to work on these house key factors. For example, the window size, the window locations, the size of the door, and also their locations. So those key important information, if we can collect them, correctly and easily, so that will be helpful for the next step to save the energy of the house. So we got this idea, and I have been working on this project since the year 2008 and until 2010. So this is a DoD grant, and the PI is Dr. Haorong Li. He's an associate professor in University of Nebraska, Lincoln. And I was a senior researcher then, and actually that's where I graduated and got my PhD degree. So let's talk about the basic idea of this. So for those houses more than 30 years, for example, those kind of houses actually they are too old. Actually, in none of those traditional softwares, we cannot find the digital models from the software. So if we want to remodel that, we have to send out the engineers to the exact house and back and forth for several times to get their solutions. So this caused quite a lot of trouble. And if we can save that by using of the Google map like this, okay, especially the top view, okay, the bird view, I mean. So from top to the deep, and how can you observe the view of the roof. So the Google Earth may be the best way. And also we ask the customers to send us some photos to help to detect these informations. So this is an example to detect these informations. Like this dark green part, those are quite important information. The size, the shape, the area of their windows and the door will be the target of Earth. So for more details, actually, if there's a house there, so we split the functions actually into several parts. On top right of that, actually, we are trying to plot the outlines in white. And in the left and bottom part, this green lines actually, those outlines has been modified. So this is more clear to represent the house. But you still can see some noises actually, especially on the road. So because this is based on the software, automatically detect this kind of thing. So there are quite a lot of noises. For example, the side of the road, and also some shape on the law. So quite a lot of noises may influence the detection result of the house. So the basic question is how can we improve the quality of the detection? So this is the first task. For example, we expect to detect the roof. So there are quite a lot of clues to detect the roof. For example, if we can locate the house and we know the roof always will be above the windows. So this could be some clue. And the color of roofs always be the similar colors, and the area could be very large. So quite a lot of clues actually can help us to detect these yellow areas. And actually there are more. So the detection could be a multiple detection method. And actually we use the technique is so-called green level co-occurrence matrix. We use this to detect not only the yellow roofs and also those wall areas in pink. Because actually the roof is much easier. You can imagine the unified color and always on top of the house. And also sometimes we can even use the sky color because the roof is always contact with the sky. So quite a lot of information can help us to solve the roof problem. But comparing to the roof, you can see the pink colors actually to detect the wall. There are quite a lot of troubles because you need to distinguish the wall areas with the windows. You see some part of the window actually has been detected as a wall, so which is a little bit wrong. But again, that's from the software. So sometimes you cannot get the 100% correct detection. So we just try our best. And now so far, based on this kind of techniques, we can get the correct rate as high as 84 around. So this is good enough for the application of the following uses for the energy solutions. And so let me talk more about the green level co-occurrence matrix. So for example, as from our naked eyes, we can recognize so many things, millions of different things. We can see this is a chair, this is a bottle. So, but we cannot maybe immediately tell you why I call this as a bottle and why I call this as a chair. Because actually, we have some kind of information just directly from our common sense. We do not explain that. Similarly, actually, we used in our software we use mathematical models to calculate the relevant informations in the image. So actually, we do not, we cannot, conclude why I call this is a roof area, why we call this as a wall area. But actually, the calculation told us actually they are in common characters. For example, in mathematics, we have the variance, we have the slope, and we have the trace of the matrix. So a lot of relevant information we cannot speak out directly, but actually we can make use of that, and this can help us to get a better result. Okay. And in a lot of other areas, actually, for example, on the right of the figure, actually you can see on the wall of the house, actually we have a lot of curves. So again, we can make use of them. But maybe, by naked eyes, we can see this is a wall, we can see that. But how can you let the software know that? So this needs the nonlinear algorithms to help us to detect that. This is also belong to this term, grid level co-occurrence matrix, all right? And the next step is the windows detection. For example, on the left side, this inside of this blue frames, okay, and the door is framed as a red frame, okay. So the first thing for windows detection is we need to recognize the shape or the pattern of the window. So you can see, for example, in this ABC 3 figures, the shape could be rectangular, or could be elliptical, or could be a semicircle. So in the database, actually, we have quite a lot, actually, more than 8 different shapes of the windows in the database. So we picked, these picture components and then compare that from our database. So how much percentage they will be matching together? So if they are matching well, so we can detect, these different shapes of the windows. So this will be the first step to detect the window. And the second one is, most of the windows are, with their glasses. And those glasses actually, because of the chemical components of the glasses, especially, the light is reflected, and, we take the photo and we take the reflected color from, the natural light from the sun. So actually, those color, if we make some change of the image, so you can see, actually, those windows can show the pink colors. So those can also be helpful for us to correctly detect these windows by filling in this pink color component in the image. So by this way, the successful rate to detect the windows could be improved greatly. And this could be the third question, because we like to plant trees, okay? But for the solution of the house, how to detect the windows, with the trees, this will be a big trouble, okay? And the solution we tried is to, take many photos around the house. So it's kind of like the movie. It's kind of like a moving frames and a movie. So we use multiple pictures, and then we use the software to eliminate the block of the tree. So you can see the result at this A part, and especially in the C part. So this is the best result so far. Of course, maybe it cannot be recovered 100%. There's still some missed part in the middle of the C picture, but this will be much better than the beginning. For example, the first row of the pictures. So in my area, we think to use more information by applying more than one pictures to fix the picture, and then the result will be in part C. And so we finished the first step. We tried the best, and we use the artificial intelligence in the software to detect the old models, of the house actually automatically. And we expect to get some conclusion and post them in a database, okay? And we can use them nationally. So the next step is how to lay out this extraction from the natural image processing. So we want to get some models of this kind of house. So you can see these outlines as in white, as in color for pink, as in color for green. Why we have these green colors and why we have these pink colors? Because only those white colors of the outlines actually is picked from the image of the house. But unfortunately, some places, for example, the boundary of the roof is very hard to detect. Okay, so we only have limited information actually from the natural picture, but we need another part of the artificial intelligence to fix these roofs and also fix the baseline of the house. And this can be also helpful to give us, a full picture of the house in a digital way. So another part of the artificial intelligence techniques has been used to fix in this picture and to add this green color for the roof and to add the pink color, at the bottom part. And then part 2 is a 3D modeling of a flower plan. So we use 3D modeling software environment. The GUI player as a Flash, and educator we use a Flex, and the language is action script. So after we collect this key important data, and also we ask the customer to submit the photos and also the size, some key parameters of the house to us, okay? And with these key parameters and the photo we have taken, we use a software to rebuild a 3D model of the house. So this will be helpful for the future design of the solutions of the energy saving house. So this is our interface of the Flex software, and we can build up the first floor, and then continue to build up the second floor. And that will be done for the 3D modeling of the floor plan. And the idea to use that actually is for the next step. That's combined with my next research interest in the wireless sensor network. So because the wireless sensor network is very cheap, and it can monitor the house for 24 hours. And it can give us multi-dimensional information for the whole house and for the energy information. So we build up the model, the 3D model, and we can think to embed these wireless sensors with the power cord inside of the house, especially around the window, around the door. Again, they are key important places for the energy leakage. So here we will add more sensors for this kind of data. And for big buildings, for example, the classrooms, the medical center, the schools, so we think to apply more sensors, and actually we call this as a sensor system. So on top of this, actually this is a kind of a sensor to detect, for example, the image, or we use other sensors for the temperature, for the air compressor, this kind of thing. And those kind of information will be collected with this chip. We call this, in the red, we call this as a PMC. So this PMC, actually, you can see that that one is with a small computer, with a small CPU, and also it's added with a small memory. So the cost of that is not very much. It's just around $150. And this one will be helping us to do some a little calculation. And, but most of that actually data will be transmitted through this so-called CMAX. CMAX is kind of a multiplexer to collect several sensors information and then transmit to the next layer, tier. I'm sorry. So CMAX will transmit the data to the field computer, okay? And all of them actually are in the field, in the hospital, again in the school, and the field computer is more powerful than the very red part, the PMC. So this can calculate, with much faster speed, and also it can have a much larger memory, and so it will store a longer times, historic data from the inside of the field computer. And I worked with a detail controls company on all of these hardware. Now this hardware actually has been used in quite a lot of huge buildings in the state of Nebraska. And this is a basic plot of this automation system, and we call this as a smart building system. So those bottom 5 blocks actually are representing 5 different sensors. Again, they could be temperature sensors, the pressure sensors, humidity sensors, and some analog data or digital data for the fan pumping or for valve. So a lot of data could be sensed and then could be connected to the field computer. And the protocol of the line we use is 485. And this is the interface of the software. Actually, this software could be monitored actually remotely. So if you are working actually at house or in another office, branch of the office, so you can still monitor the building actually far away. And you can even control to turn on and turn off different facilities by using of this software and the controlling system. So actually, different people will be set up, different account. And some of the higher levels of the engineers, they can turn on and turn off these kind of facilities. But maybe another group of people, they can only check the status, but they do not have the right to change that freely. Okay. So this software gives us quite a lot of flexibilities and freedom to just drag and drop and point and click. So easy to use these graphic facilities to modify the whole system. And these are some curves actually stored in the field computer. Okay, so through this software, you can immediately check out, what's the string point. For example, on the very top of the figure, you can see 2 specks. So this may, some problems happen at that time moment. So maybe it's in the, 3 a.m. in the midnight. So maybe no engineers is monitoring that. But, tomorrow, you still can go back to the history of the data, and then you can analyze what could be happened, and then you can, go to the field and to solve that laterly. So this is the data from the field computer, and they are also very useful. And we also designed this offline and online data selection. So this is for, in some case, if these data are very important, but unfortunately, maybe there could be some power off time, but you still want to store this kind of data. So this field computer is especially designed for a very tough environment. And this is about my talk about the whole design. So any questions?
I had a question on the Detecion software and
Mm-hmm.
some of the points that you were measuring as well.
Mm-hmm.
This graphic.
Mm-hmm.
Depending on what unit or what band or what piece of equipment is there any protocol that you had to make sure that you were able to read the information and data? So was there anything that is required?
Oh, yes, yes. The first thing is you need to get access to the system first. Otherwise, you cannot see that. So you use the internet, but the security and the privacy will be very important. So there will be one person to be in charge of their responsibilities. So only limited person can get access to this to see that, and only several people can modify that. And there will be some record, like filter. You actually changed that. There will be a record for that. So if this is changed wrongly, somebody else, they can check the record and they can read that. Oh, you did that. So what's the reason? So, and also there's a place to post some note on that. So what's the reason I changed that in which time, and I found out what kind of problem. And also the function is, you can not only give some note on that, but also you can send out emails through the system. Yeah.
I wasn't sure if it was depending on whose equipment it was or software, if there was some sort of restrictions, or they had different types, just an inability to communicate. So I wasn't sure if there's something that you had to put into the system. Did you have to get special permission to be able to
Um, no, actually, it's not that. So it's very strict because it's very important. You cannot feel free to change that. So if you are not assigned the right to modify the parameters, so you just cannot do that. You even cannot have chance to apply that lately. Yeah. Only limited person actually who are in charge of that, because we allow this software to change the facility remotely. So this actually is some kind of dangerous. So if you are some person, you are not familiar with that, but you change that remotely, that's actually, it's kind of, remote explosive, I think.
Is that an issue, though, for security, for the wireless abilities to, and how can you increase the
Yes.
security of something like that?
Yes. Actually, from the protocol of the wireless communication, we did some work to promise security. So actually, we encoded the communication for that, so nobody else can try to open this kind of thing. So this is an important concern actually in these applications. It's a good question. Yeah.
Thank you very much.
Thank you all.